Have you ever gazed at the star-studded night sky and wondered, how did it all begin? It's a profound question that has puzzled humanity for ages. The universe, in all its vastness and complexity, how did it originate? The most widely accepted explanation to this question is the Big Bang Theory, a monumental cosmic explosion that marked the birth of the universe. It's a fascinating yet complex theory, filled with mysteries and marvels. To answer that, we dive into the fascinating, albeit complex theory of the Big Bang. Around 13.8 billion years ago, something extraordinary happened. It was a spectacular event that marked the genesis of everything we know, everything we see, and all that we are yet to discover. This event, my dear friends, is none other than the Big Bang. The Big Bang wasn't an explosion, as its name might suggest. Instead, it was the very moment when the universe, as we understand it, sprang into existence. Picture it as the starting point of a grand cosmic journey, a journey that's still unfolding, even as we speak. Imagine, if you will, a state of singularity, an entity so incredibly dense and hot that our current understanding of physics can barely comprehend it. It's like everything that exists, all the stars, galaxies, you, me, and even time itself, was condensed into a single infinitesimal point. This, my friends, was the initial state of our universe. But then, something phenomenal happened. This singularity couldn't contain itself anymore. It started to expand, and it did so at an unimaginable speed. This rapid expansion, which we now call the inflation, was so powerful that it transformed the singularity into a vast, ever-expanding universe. During this inflation, the universe cooled down, and the fundamental forces of nature that we're familiar with today, gravity, electromagnetism, and the nuclear forces, started to take shape. The universe, which was once a hot, dense point, quickly became a spacious, cooler cosmos filled with energy and matter. Think about it. The planets, stars, galaxies, and even life itself, everything originated from this single, extraordinary event. It's an idea so profound that it changes the way we perceive our existence. The Big Bang, in essence, marked the dawn of space and time. It was the starting point of a cosmic journey that's still going on, a journey that has led to galaxies, stars, planets, and even us. In a fraction of a second, our universe was born and began to grow. It's a story that's as fascinating as it is complex, and we're only just beginning to understand it. The universe in its infancy was a hot, dense soup of particles. Picture a baby universe just a fraction of a second old. It's seething with energy, expanding at a mind-boggling rate. This is the period of cosmic inflation, a time when the universe grew exponentially, doubling in size again and again in the blink of an eye. But this wild expansion couldn't go on forever. As the universe cooled, the energy that once fueled inflation transformed into a sea of particles. This was the birth of the fundamental particles, the building blocks of everything we see around us today. Quarks, electrons, and their anti-particle counterparts jostled together in this dense, hot, cosmic soup. Now let's take a step back and think about something. Where's the light? It's hard to imagine, but in these early moments of the universe, there was no light. The universe was opaque like a thick fog. Photons, the particles of light, were trapped, bouncing off the dense soup of particles. But as the universe continued to expand and cool, something wonderful happened. The quarks combined to form protons and neutrons, and these in turn started to form atoms, creating a cosmic sea of hydrogen and helium. This was a pivotal moment, the recombination era, when the universe became transparent to light. And for the first time, light could travel freely through the cosmos. This light, the afterglow of the Big Bang, is still detectable today. We call it the cosmic microwave background radiation. It's a snapshot of the universe at a very young age, a baby photo if you will, and it provides us with invaluable information about the universe's early moments and its subsequent evolution. As the universe cooled and expanded, it set the stage for the formation of cosmic structures. The stage was now set for the next act in the cosmic drama, the formation of stars, galaxies, and all the cosmic structures we see today. But that's a story for another time. For now, let's marvel at the journey the universe has taken from a hot, dense soup of particles to the vast, star-filled cosmos we call home. With time, the universe transformed from a uniform soup to a cosmic web of galaxies. In the beginning, the universe was a dense, hot, homogeneous mix of particles. However, as it expanded and cooled, slight variations in density began to form. These tiny ripples in the cosmic soup were the seeds of future galaxies. The primordial gas clouds, primarily composed of hydrogen and helium, began to clump together under the relentless pull of gravity. As these clouds grew denser, pockets of gas began to collapse under their own weight, forming the first stars. These were not the familiar stars we see today. They were massive, and their lives were short and explosive. These first generations of stars didn't just shine, they reshaped the universe. Their nuclear furnaces forged the first heavy elements, such as carbon, oxygen, and iron. When they exploded as supernovae, they scattered these elements into space. This stellar debris would eventually become the raw material for new stars, planets, and eventually life. Meanwhile, gravity continued to sculpt the universe on a grand scale. The denser regions of the universe attracted more and more matter, growing into galaxies. These galaxies weren't the elegant spirals or elliptical shapes we're familiar with today. They were small, irregular, and chaotic. But over billions of years, they collided and merged, growing into the colossal structures we see now. And within these galaxies, new generations of stars ignited, surrounded by swirling disks of gas and dust. In these protoplanetary disks, tiny particles began to stick together, forming pebbles, then boulders, and eventually, planets. So the universe, which started as a smooth, hot soup of particles, had become a vast, cold space filled with galaxies, stars, and planets. And all this complexity emerged from the simple, primal forces of the universe, gravity, and the nuclear reactions in the hearts of stars. From these early stars and galaxies, the universe continued to evolve, becoming increasingly complex. Fast forward to today, the universe is a vast, dynamic place, teeming with galaxies, stars, and planets. It's an immense expanse of space-time that stretches out for at least 93 billion light-years in diameter, housing over 100 billion galaxies. Each of these galaxies is a cosmic city, home to hundreds of billions of stars, each star potentially hosting its own system of planets. The universe as we know it is not a stagnant entity. It's very much alive and in constant motion. Galaxies are moving away from each other, the universe is expanding. This cosmic expansion is a fascinating phenomenon, first proposed by Edwin Hubble in the early 20th century. It's like a loaf of raisin bread dough rising in the oven. As the dough expands, the raisins move farther apart from each other. Similarly, as the universe expands, galaxies drift farther apart. Within these galaxies, life as we know it unfolds. Stars are born from clouds of gas and dust, live out their lives by fusing hydrogen into helium, and radiate energy as light and heat, and eventually die, often in dramatic supernova explosions. These explosions scatter elements like carbon, nitrogen, and oxygen into space, which can then form new stars and planets. Planets, like our very own Earth, are celestial bodies orbiting around stars. They are diverse in their composition and climates, from gas giants like Jupiter and Saturn, to rocky worlds like Mars and Venus. They may hold the key to one of the most intriguing questions. Are we alone in the universe? The universe today is a testament to nearly 14 billion years of cosmic evolution. It's a place of unimaginable scale and beauty, a place of extreme temperatures and intense forces, a place where the laws of physics create a cosmic symphony of galaxies, stars, and planets. And here we are, tiny specks in this grand cosmic arena trying to unravel its mysteries. So, how did it all begin? This question often teases our curiosity as we gaze upon the night sky, pondering the origins of everything we see and don't see. We journeyed from the Big Bang, the fiery birth of our universe, which was not an explosion but an expansion, an unfurling of space and time itself. In the early universe, a dense soup of particles began to cool and expand, paving the way for the formation of atoms. As the universe continued to grow, these atoms started to clump together, resulting in the formation of stars and galaxies. These celestial bodies and systems became the building blocks of the universe as we know it today. The Big Bang theory has been instrumental in helping us understand these processes. It's a scientific masterpiece, weaving together elements of physics, astronomy, and cosmology into a coherent narrative of our cosmic origins. However, it's not without its limitations. It tells us how the universe evolved but not why or what caused the Big Bang in the first place. This leaves us in a fascinating position. We have a solid foundation of knowledge, yet there's still so much we don't know. While we have some answers, the origin of the universe remains one of the greatest mysteries in science, reminding us of the grandeur of the cosmos and our ceaseless quest to understand it.